Assalamu alaikum. In this task we will be making a calculator that can add and subtract, and the logic we will be using would be for only for addition and subtraction based on our assembly language. And now coming to the softwares we will be using, we'll use Proteus 8.10 and ATMEL Studio for assembler coding. After that I will come to the logic. So first of all, I'll introduce you to the hardware we will be using, to the components we will be using in Proteus. Here we have got our keypad. This is the 328P, the IC for Arduino Uno. These are 7-segment BCD displays, and this here is a chip named MU74C922. This is for making these 8 bits into the 4 bits that we can introduce here in our Arduino Uno input pins. So first of all, coming to how we are going to do it, if we can see this keypad right here, it has got 16 buttons, these 16 buttons, and the combinations we get out of it are ranging from 000 to 15, which is 111 in binary. Now here we connected this keypad with this C922, and we have grounded these terminals. Here we have connected the 8 pins coming from this keypad, and right here we are getting our combinations as output from 000 up to 1111, and these are total of 16 combinations. So based on the button we press and the combination we get, like if I press 2, I am getting 0101, and if I press 0, I am getting 01111. so these, based on these combinations, we have drew another table that is telling us about the button we have pressed. Right here, for example, if we were pressing 0, we were getting 011, which is right here, and when we press 1, we get 1101 in the last, and the starting pins we are not taking because we have got 8-bit port right here. So here we have written down all the operations we needed a total of 12, these from 0 to 9, and 2 for our operation of addition and subtraction. So first of all we made that table, and then coming to the logic we made in our ATMEL Studio. Okay, right here in ATMEL Studio we have made an assembler executable application, and I will take you through the code step by step once. Okay, so here our code is starting, and we have set up some so Arduino has got like our 31 general purpose registers. So in register number 19 I have set up the value of 0xF0, which means the first 4 ports are going to give us output, and the next 4 ports where we will take our input from our keyboard, from our keypad, and these are the rest of the pins for our in R20. We have stored all as 1 because we are going to set our pin B as output. And now this is another register value of 00, which we have just taken to check if the value for the calculator has changed in the start or not, because as a general it's 0, and we don't want to get 0 as any form of output, any form of input. Now here we have declared our DDR, the direction of the D port, as R19, which is right here, which is first 4 ports are output and last 4 ports are input. And then we have got this, we have set our direction of DDR-B as R20, which is we have set all of the ports B, all of the DDR-B as output, which means we are going to get our output at port B. So after that our program will jump to start. So here in start we have got 3 things. For any general addition we are going to have like 3 characters, 2 plus 2 for example. So we have this as first, this as second, and this as third. So we need three inputs, first input, second input, which is some exponent and an operator, and the third input which is our second operand. Now here we have got our input from pin D stored in register 21, which means that we have got our first operand, and we have compared it with R18, which was 0, to check whether our input has changed from 0 or not. And after that, if it has not changed, we will branch back to in1 until user gives some input, else we'll move to in2, which means we are going to get our operator. So we'll get our input and store it in R22 as just to store our operator, and we compare it with the previous register 21 right here to check that the value from the keypad has really changed and we are not storing the same value as was before. If it has not changed, we'll go back to in2 until the user enters some operator. After that, we are going to move to in3, and in 3 we will be storing our value in register 23. Again, we will compare, we are storing it in R18, so that when the next operation begins, we are not getting our value back as in 1 and it directly jumps to in 2. So just to avoid that, we have stored it in R18 so that we can operate the very next operation simultaneously. So we compare our register 23 and 22 just to check that the value has changed from the operator, and after that we store it in register 23. So we have got all our values. Now as we know that we were getting some wrong values and we were not getting exactly what we wanted, and we have noted down these values were what this means. 0111 means 0. It is not 0111 actually, so we want it to be set to 0000. So we have made certain conditions for that. So first of all, we are going to set our first exponent or operand. First of all, we are going to set our first operand's value, and like here we have got this, and when actually we are getting this, we want it to be 0. The 0111 is actually 0. We don't want it to be as this value gives 8 plus 4 plus 2, which is 14. It's not actually 14, it's 0, so we'll set it to 0. So if this matches the value, it will set its value as 0, where op0 is another label which is setting our register 21 value as 0. So similarly, we have made these 10 operations which are going to give the required value to our register, and this will be executed only if the comparison matches, and then it jumps to the respective operation setting its value. Now after we have set the value of the first operand, we'll move to setting the value of the second, which is whenever the value is set, we'll just jump to the very next set value of the exponent 2. Okay, and after that, here we compare the value for register 23. Register 23 is our second number, which is to be either to be added or subtracted, but it's our second number. So here we get all these combinations, we match it, set its value using OPE operations. OPE are just labels, and here I have defined them, which is setting the value as same as we just saw right here in this table, that we were getting some wrong values and we wanted them to be corrected. And after it has been executed, whichever value it is, it will jump to the operation label. Operation label is right here, and it's responsible for checking that whether we want addition to be performed or whether we want subtraction. If we want addition, it will jump to addition function, and if we want subtraction, it will jump to SPF, which is subtraction function. These are again just labels and no commands. So in addition functions, we will be adding our first value and the second value, R21 and R23. So based on the decision, which was the operator, which was the register 22, we made our decision whether we want to add or whether we want to subtract, and we just reflected the change on port B as output, so which will set our port pins and give us the output. So after that, we will just go here, click on build solution. It will build the solution. Then we will just left click, open containing folder, and in the debugging folder we will get right now, here we have this hex application. This is the path we want to give to our circuit, for which we can either upload to Arduino using an Xloader, or we can also just upload it on Proteus. So we'll copy this path right here, and now we'll move to Proteus. So coming here we have got some hardware. These are BCD segment displays, 8 segment displays. These can display up to F0 to F, which means it's displaying in hex. And here we have connected these pins right here, this being the LSB and this being the MSB. Here this being the LSB and this being the MSB, least significant bit and most significant bit. And here we have got our inputs right here. So this being the least significant bit, and this being the most significant bit, and this being the least significant bit for the input, and this being the most significant bit for the input. And we get our input right here, and we reflect it right here. These two were out of range because 9 plus 9 equals 18, and it was never gonna use these two anyways, so I just gave them a logic 0, which means a ground in practical. So now we'll double click this right here. First we'll have to pause the simulation. Okay, double click right here, and here we are going to give the same path which we copied right there. First control A, and we'll just paste the path. And okay, so we have just given it the path to our hex file, and now we'll be simulating. So this right here is the simulation. So for 2 plus 2 we get 4, for 6 minus 3 we get 3, for 5 plus 5 we get 10, which is A in hex. And similarly we are getting all the other operations performed. 9 minus 3, 6. So it's working pretty well. So this was all for this video. Thank you. Allah Hafiz.